Okie doke, I can see people are joining us now, so I would just like to start by saying hello everyone and welcome to our engineer interview with Vish. My name is Scott and I'm your host for today. Before we start, I'd just like to say thank you very much for signing up to the competition this year. For those of you who don't know, this is the Leaders Award competition, where we ask the question, if you were an engineer, what would you do? Pupils from the ages of 3 to 19 anywhere in the UK can join, and every single person who takes part receives a graded certificate from a real-life engineer, just like the ones we interview. Now, the deadline for submissions this year is March 22nd, so make sure that once you've finished the competition in class, you get your entries sent in to us. We're delighted to announce that we actually have some free posts available to schools, thanks to the support of our national partner, Talis. So if you would like to see if your school's eligible, simply get in touch with your contact at Primary Engineer. Now, during these interviews, we're going to be speaking with engineers who work on loads of different projects, all of them showcasing the wonderful, interesting and exciting things that happen when you work in engineering. Our special guest is going to start with a 10-minute presentation about his work with Network Rail, and then that's going to be followed by some questions. If you do have questions, simply pop them in the chat and I will read them out to Vish after the presentation. But for now, that's going to be enough for me. I'm going to hand over to our special guest to start the presentation.
Thank you, Scott, and good afternoon, all.
Perfect.
So I'm absolutely excited to be here today. So I work for Network Rail. So what is it we do? Right, like we own, operate, and develop Britain's rail infrastructure. Now, most of the people, when they talk about railway, they can think only of train. And hopefully, within the next 10 minutes, hopefully I will, cover the areas which may not be so visible to the common people. So there are clearly lots of miles of track, bridges, tunnels, viaducts, and thousands of signals and level crossings and stations. Well, there's a lot of terminology in there. So what exactly is a viaduct? I won't go on to explain, what is meant by a tunnel or a track. Track is something which, on which the train runs. A viaduct is actually a long bridge-like structure, typically a series of arches. And normally it is, it carries either a road on top of it or a railway. Signals. So signals are very similar to the traffic light signals, what you have seen. And the level crossing is a very important. So this is the place where the railway and the road, or two railway lines, they cross at the same level. So why am I emphasizing on level crossings? Because it is a very dangerous place on the railway. Because we share it with other people, there's often a tussle as to who's got priority on top of, like at the level crossing. But no prizes for guessing. When you are seeing an oncoming train, everybody else loses. But again, train is also a loser because obviously it is going to get detrained and there are lives at stake. So safety is paramount. So I did talk about lots of miles of.
Oh, sorry, Vish, you've just got on mute. Sorry.
Yeah.
Oh,
sorry.
there you go.
The thing you right. So, sorry. Yeah. Now, so that's about 20,000 miles of track. That's what we are talking about. And how long is 20,000 miles? It is from UK to Antarctica and back. So it's a lot and lots of tracks. These things, viaduct seems to be coming, quite often in the presentation. So there you go. That's an example of a viaduct. And if the participant would like to pop into the chat, this has been immortalized in the Harry Potter series. So what is the real name of this viaduct? Just the name, please. And keeping in theme, if you wonder where my officers would be, it is on the second floor of this particular station. And also, if the participants could pop into the chat as to where do you think my officers would be? That would be brilliant. Now, what is it we do? We actually exist to get the people and goods where they should be. Now, the railway itself, most of us are familiar with the passenger thing, but the goods and the freight, as it is called, they are also very, very important because the railways do provide with a very economical way of moving goods across large distances. So, so these are the normal types of train which one would encounter, except for the one at the bottom right-hand side. So the railway is not all about, freight and passengers. It's also about maintenance. And the train which you're seeing there at the bottom right, that's actually like one of our maintenance train. So the train itself, somebody might be wondering as to how fast can a train go. The fastest train on the British network is the Eurostar, and that goes up to 186 miles per hour. And the reason it can go at high speed is because it has got a dedicated track to it. So it doesn't share the track with other trains. So at any given time, there is a Eurostar on the track, and that's the reason why it can go at such high speed. But if people are traveling from London to Birmingham or to Glasgow, they will encounter what is called as a pendolino or a tilting train. Now they can go up to 125 miles an hour. Somebody might ask, if the train can actually go up to that speed, why don't we run the trains fast? Like that way people can reach the destination quicker. Interestingly, the challenge is not speeding up the train, it is actually stopping the train. That is the challenge. So a braking distance of a freight train or a goods train can be as long as 2 kilometers. So the driver needs to be told 2 kilometers in advance for him or her to start braking so that the train comes to a stop safely. Now, and the time in which the train would travel is about 80 seconds. So we are talking about a minute and 20 seconds. So even if somebody looks at a danger, the time they take to react is actually quite long. So that's why we need to run the train safer so that it can stop at a particular time. Right. I'm just going to show a small video, and bear with me while this loads up. So this is basically to look at the way we are trying to do the digital signaling.
Basic signalling keeps trains and people safe. Two trains are travelling in the same direction, and we need to prevent any accidents. So we divide tracks into fixed sections called block sections. Block signalling manages the movement between block sections, when to stop and when to go, like traffic lights. If a train misses a red signal, the emergency brake, or TPWS, train protection and warning system, is applied. Together, they keep trains a safe distance apart. But there's a different problem. The railway is full in some important places, and this system is becoming constrained. The infrastructure is physically fixed and unable to identify the capabilities of individual trains. It can't adjust, and the timetable has to assume longer intervals, which restricts train performance and lots of space is wasted. So how can technology help? We replace these line-side signals with wireless technology on the train and on the track that can talk to each other. Now, the infrastructure can identify the train, accommodate for its needs, and optimize space. Intermediate markers installed along the track will make block sections variable, so more trains get through. Trains pulling into a terminal station vary in braking capabilities, so all trains start braking early and arrive into stations very slowly. But by identifying the train and coordinating the timetable can be coordinated to operate in intervals of seconds. This digital train control technology is a computerized in-cab signaling system designed to get more trains running. So what does this mean for train drivers? Nothing's really changed in a long time. Drivers look out for block signals, but often there are lots of tracks and lots of signals which can be complicated to decipher, especially approaching major cities or in disruptive weather. Miss a signal and the train's protection system kicks in. But when one train halts, others may have to wait, causing a domino effect until the train recovers its service. Here, technology can help. Put all this signalling information at the driver's fingertips. Now, it's easier to communicate when it is safe for a train to proceed, take appropriate action, and improve the performance of the train. This is a valuable help to train drivers, and is an even safer system for passengers. Plus, having the technology on the trains is safer to maintain. Less time is spent trackside on fixed infrastructure, as all trains go home. A computerized system can self-monitor. It can predict and it can prevent problems before they happen. Another part of digital railway technology is traffic management. The brain at the centre links to train information across the system, meaning passengers can be kept better informed when things go wrong. In traditional signal boxes and new operating centres, staff are busy keeping the service running. So if things go wrong, it can be a complex operation to manage. Technology can ease this confusion. A computer can look after thousands of trains and staff operating on the network, monitor the system, and present corrective options to support signallers in making their decisions. Simply, traffic management knows where trains are and manages the timetable in the most efficient way to minimise delays. Integrated technology unlocks real-time information for drivers, information that is currently scarce. Connected Driver Advisory System, known as CDAS, provides drivers with this real-time information and advice on how to manage the performance of the train. Automatic Train Operation, ATO, allows the train to drive itself on autopilot, leading to more consistent operations with the driver focusing more on safety and passenger experience. Over time, less line-side signalling equipment will mean a more cost-effective railway. These technologies will make the digital railway a better performing, higher capacity and safer railway. A modern railway for Britain.
Thank you. So that was basically to give you an insight about, what happens on the railway, the challenges we are. Now, just being conscious of the time, and what I've said earlier on about the way Network Rail manages the entire country is that we are divided into 5 regions, and the regions are then divided into routes. So some of the things, apart from managing the infrastructure, is we are one of the biggest landlords in the UK, because clearly all the area and the land on which the tracks are laid are ours to manage and maintain. But we look after 20 stations, right? All the big stations, be it Glasgow, Edinburgh, Birmingham, Liverpool, Manchester, London, they're all managed by Network Rail. Now, railway itself is a sort of an ecosystem wherein we also deal with things like power. So because most of our trains, they are electrified, they run on electricity. So we are actually if we were to start an electrical company, we would be the 5th largest electrical company in the UK, because that's how much we consume. So there are opportunities for my colleagues in telecommunications. So the railway telecommunication, just like emergency services, have got their own frequency. So we have got our own network on which, we communicate. That, like civils and operations. So what I mean by that is things like drainage, ducting, so on and so forth. So all these kind of areas, which are areas of engineering which you normally do not associate with the railway, they in fact are very, very important on our infrastructure. Needless to say, we are a very sustainable railway. We make every effort to make sure we reduce like the carbon emissions by using sustainable materials, where we can improve the air quality, minimize the use of fuel. So there's a lot of research and development also being done. So the picture here, it shows about how we are trying to reuse the ballast. So ballast are the things which go like, underneath the sleepers. So these are the ballast. And as you can see, like my colleagues, they work in really a very unforgiving environment. And so day in and day out, rain, snow, sunshine, they are out there trying to sort of install and maintain, the equipment. So clearly, it has got its own set of challenges. Uh, Theft is one common thing. So where people actually steal the cables, like looking at the value of it. But unfortunately, it has got no value in the market because most of our cables are fiber optics. But that actually causes disruption to the railway. So I'm going to skip this next slide because I'm just conscious of the time. So one of the things which people wouldn't be associating railway with is drones and helicopters. So these technologies are actually used to help us reduce our own workload, because a drone and a helicopter can actually do a survey of a line much quicker than I could personally do. So how did I get about it? So I started off as an electrical engineer, me myself, and then my first job was with the Navy. So I was on a warship, and then I came to railway about 25 years ago. So I worked on the railway supplier, it's called Alstom, who makes trains. I worked with London Underground. I've come to Network Rail, and then wherein currently I'm actually looking after cybersecurity as well now for the railways. Next year, we would be celebrating 200 years of train travel in the UK. So the world's first passenger train was hauled on 27th of September 1825, and it carried 400 people. So, we've got a long history. And I think that is the time for me to end my presentation. Thank you.
So thank you very much for sharing that. I actually can see as well, there's a few people guessed that King's Cross is the train station that you work at in London. So if anyone has any questions out there, please start typing them in the chat. We've had some sent in, but I've got the first question for you, Vish.
Yeah.
What do you love about your job?
So my job is very variable. So as an electrical engineer, I look after introducing new technologies. So the challenges which I face can sometimes be very complex, but the solution is very simple. So take, for example, a mobile phone. Now, there is a reason why mobile phones are not used in petrol stations. So, because of the fear of igniting the fuel. Similarly, some of the equipment have got a very similar effect on the railway, wherein the signals would actually react differently to a certain frequency. And you don't realize it until you test it. So the reason I gave that example was basically, like every new technology introduction comes with a different challenge. So I don't have 2 days similar to each other at office.
That is pretty exciting. Yeah, the variety sounds amazing. In fact, we've got more people asking what you do. We've got Caleb and Nathaniel have asked, do you get to fly the drones?
Me personally, no. But there are specialist people who fly them. And the drones actually have been introduced quite recently. And sometimes we use it basically where it is very dangerous for people to go physically to get the first-hand information before we send a team out, and also to check, because if we want to send people out, we will have to close the railway. As I told before, a train and people don't go together very well unless one is sitting on top of the other one. So So yeah, so I personally, I don't fly the drones, but my colleagues do.
And it sounds like they're used for what you said was the most important thing, which is safety. So it sounds
Yes.
like it's a way to make sure the people go out there. Now we've got a question in here as well. Now we know that there's 20,000 miles of track in the UK. Have you been on all the railway tracks?
No. I have been on tracks near Birmingham, Manchester, and Swindon. But no, I don't think I can walk 20,000 miles ever.
We've got some questions coming in about yourself, actually, Vish. This one is, what inspired you to become an engineer?
So, like, as a young boy, I always was sort of more mechanically minded. Uh, so I had physics and maths at school. Uh, so what used to fascinate me was actually, building blocks, things like Lego and mechano sets, these kind of things. Like I used to play with them, and I thought like I could actually take it as a career. But I ended up in electrical engineering, which is very different to mechanical aspects of it. Uh, and the only reason I ended up in electrical engineering is maybe I was not as smart as I should have been to get into mechanical. But then, like again, like electrical engineering, once I've done it, like I think I've managed to accomplish whatever I needed to do. So I started off as an electrical engineer, and today I'm looking after cyber. So it's it sort of molded itself gently into my aspirations.
Yeah, there's such variety, as you say, in engineering. In fact, one of the things, and you mentioned it with drones being a new thing and how your career's changed, there's a question here about the future. Caleb and Nathaniel ask, what do you think the railway network is going to look like in 20 years' time?
That's very good because we have a strategy paper exactly exactly setting out what the railways look like. So our plan for the railway is it should be at the center of the consumer. So today we are running timetable trains. Now the timetable is basically to suit a different section of the people and not the consumer. So we are sort of looking at an Uber on demand kind of a scenario wherein like you should be having that option. And the reason we are thinking of it is if we could try and de-link things like timetable and the constraints which we have currently, right? We can definitely provide that particular service. Albeit it will not be like Uber where it is a seamless travel, but at least we can offer opportunities to go that way. And and again, that's both for passenger and freight. And we are trying to provide like an end-to-end journey experience wherein people can actually go smoothly without having to wait too much for a connecting train and things like that.
Wow, that's interesting. The timetable being for everyone, not for you. You don't go when the train's ready. The train goes when you're ready. I like that. We've got a really interesting question here from BFC, which is, what cyber risks are there for UK railways?
So anything which is digital clearly has got cyber risks. So the good thing about railways is even though it is well insulated and it is looking at an internal system, but we do interface with external entities and bodies. So the railways are designed to stop at the first hint of danger. So unlike people might think that the two trains will collide, that's very unlikely.
Yeah.
The only thing what might happen, either the trains might stop at a bad location. Say, for example, it might stop inside a tunnel or on a bridge, and then it becomes a challenge for us to detrain the passengers because we can't reach that inaccessible place. So we are very resilient, and we are attacked daily.
Wow.
Yeah, so just like any other major company, there are cyber attacks on our company every day. On our network, we are digitalizing the railway, and we are making sure we are putting the best of the defenses available so that a cyber attack doesn't happen. But the chances are very real.
Wow, so it's definitely keeping you busy then. Um, we've got another question here. This one comes from David Nee, and David asks, do you have to do a lot of traveling with your job?
Yes. So, as you know, railways are all across the world. We try and share the the lessons learned from other railways as well. So I am also responsible for developing a cybersecurity standard. So I interact with other infrastructure managers, so the likes of Deutsche Bahn, SNCF of France and Germany, respectively. So we would, I go there to meet them. They come over here. So there's a transfer of ideas. So yes, I do travel.
Wow, yeah, and speak to a lot of interesting people a bit as well. And one of the questions we got sent into us is about how you work. So do you find yourself working a lot on your own, or do you have to work with a lot of people?
No, everything is about teamwork. Everything here is about teamwork. So there are different areas where, like one would specialize. So for example, like if I were to say I specialize in cybersecurity for the time being, then I would provide an input, and that would be assessed by my colleagues. So clearly, like we all work in a team, and the railway is all about teamwork and safety, because we have to look out for each other.
Brilliant. So I mean, it's not a lot of you in a room on your own. It's a lot of talking to people and people all over the
Yes.
UK and the world, by the sounds of things.
Yes.
So we've got time for a few more questions. If you've got a question up there, please send it in. We've got one question that's come in, which is, what would happen if a train short-circuited? So what happens if a train loses power?
It would come to an halt. So and it has happened. So because, like I said, there is no reserve power on a train, but you can actually try and move it. So should that thing happen, we sent a rescue train to sort of either push or pull it to a place where we could attend to it. So most of the trains are equipped with locomotive in the front and at the back. So if one of them fails, there is an option to actually go to the other locomotive and drive it. But you can't drive from a rear locomotive. You can't go forward. So you'll have to go the other way. But then you'll have to need to block the railway and make sure you get the stranded train out.
And then is there lots of because it looked like from your video as well, there's lots of technology that uses to track where trains are. So how quickly, if that happens, do Network Rail find out that it's happened?
So the first point of call is the driver. So now clearly we can see the train going from one block to the other as shown in the video. So we can see that from our control center. But the train driver are equipped with special radios, and they have got the cell phones as well. So they let us know as to which areas they think they might have actually broken down. And we then verify it with our own signaling sections, and then we send the rescue out.
So again, it's a team effort to
It
make
is
sure
a team
that
effort,
they can go out.
yes.
Yeah. We've got time for one more question. I like this question that was sent in to us. It sounds like you've had quite a varied career and you've worked on quite a lot of different things. What is the hardest project you've worked on at Network Rail?
So the hardest project has been trying to implement a technology which is being used elsewhere and having people to accept it.
Oh, so it's convincing people.
Yes. So everybody suffers from the mentality that it was not invented here. And that's why I always say there is a people, there's a process, and there's a technology element. So these are the three pillars which are intricately interlinked. So unless we get the people on board and have a process in place, we wouldn't know what to do with it. So that had been my biggest challenge, was to try and get to use this particular piece of technology in the UK, because I underestimated the challenge we had with the process and the people element. But once that was known, clearly, you tell the thing to people, they are understanding, and like clearly these things they are brought online. But that would have been prevented by a little bit of forward thinking.
Brilliant. So again, it's working with people and solving problems. Well, just looking at the time there, I'd like to bring this interview to a close by thanking everyone for joining us, but a massive thank you to Vish for helping inspire the engineers in the making out there, because now it is your turn to come up with your own engineering ideas. Remember and send them to us once you've finished so we can get our certificate sent out to you, and we'll hopefully see you all at our public exhibitions at the end of the school year. Remember, the deadline is March 22nd, so once you've finished your entries in class, make sure you send them in. But massive thank you again to everyone, and a huge thank you to Vish. And remember, if you were an engineer, what would you do?